We are going to discuss the chapter 10, the periodic law, from the book The Physical Universe by Krauskopf and Bezer. Alchemy. The medieval search for the way to change the ordinary metals into gold is called alchemy. The scientists who try to do some research on gold are called alchemists. Chemical reactions. A chemical reaction is a result of adding two things and getting a brand new thing which is completely different from the additives. Is when these things happen, we call it that there is a chemical reaction happen. If you want to explain it properly, the formation of a new substance whose properties are completely different from those of the individual substances that participate in the reaction. For example, if you're adding A with B, then you get a brand new substance which is called C, which has completely different properties from A or B. Then we say that there is a chemical reaction happen. For example, zinc sulfide. You can look at zinc and sulfur as an individual entities. You can look at zinc as shown in the picture. It is a gray metal in physical appearance and it melts at 420 degrees Celsius. It has a density of 7.1 grams per cubic centimeter and it dissolves in dilute acids and it does not dissolve in carbon disulfide. When you look at the sulfur, it has a yellow solid color and it's a solid which melts at the temperature of 113 degrees Celsius. It has a density of 2 grams per cubic centimeter and it does not dissolve in acids, but it does dissolve in carbon disulfide. When you mix zinc with sulfur, you get a compound which is called zinc sulfide, which is neither gray in color or yellow in color, but it gets the brand new color, which is the white color. And it's a brittle one. It's not the metal or it's not the simple soft solid. It's a brittle one. And it does not melt but decomposes into zinc and sulfur at 600 degrees Celsius. It has a new density which is 3.5 grams per cubic centimeter, different from the zinc or sulfur, and it does not dissolve in either the dilute acids or carbon disulfide. So in this situation, we say that zinc sulfide is a compound and which is a product of the chemical reaction when we add zinc and sulfur. Substances. Heterogeneous substance is composed of separate materials in different kinds that are not chemically combined and retain their individual properties. For example, if you are adding salt and sugar, even though they look exactly same, so you might think that they are completely dissolved or like in a mixed with, but that mixture of it will have the salt and sugar features. Another example, if you're adding pebbles and pearls, so when you're adding those, the mixture will still have pebbles features in it and the pearls features in it. So that kind of mixture is called this heterogeneous substance, which will have the individual properties retained even after mixing them. The elements. The elements are some substances which cannot be broken down or changed into any other element by any chemical means. All other substances are combinations of these elements. In other words, we can say that a part of a material which cannot be broken down into any other material or which cannot be broken down into any other material, that is called the element, which is not a byproduct of any other material. That's what is the element. And every other material is a product of one or few of these elements together. Compounds. Compounds are formed when two or more elements combine chemically to produce a new substance. The properties of the compound are different from those of the elements it contains. So the example of zinc and sulfur, so when you mix those, The chemical reaction happens and the product, which is zinc sulfide, we call it as a compound which does not have any similarity between the zinc or sulfur. So the compounds are formed by two or more elements and they combine chemically. They produce a new substance. That's the compound. Compounds can be distinguished from mixtures by two tests. One is compounds boil and freeze at the definite temperature and not altered by change of state. So they have any material, let's say water. Water has a boiling point temperature or freezing point temperature, a fixed one. But water is a combination of hydrogen and oxygen. But still, we have a one fixed temperature for the whole entire water, so as a compound. And mixtures lack the definite boiling point or the freezing point temperature, which could be altered by change of state. Something like if you are adding pebbles and pearls, if you're trying to burn them, like, probably pearls, because they are, melting point probably would be a little bit less than the pebbles. So, probably they will melt or freeze faster than the pearls. So something like that, like, these will not have definite boiling point temperature because one would boil at certain temperature, the other part which is mixed in it might uh, boil at a different temperature. Mixtures consist of elements or compounds that are not chemically combined and retain their characteristic properties. The mixtures could be of two different types. One is heterogeneous mixtures, in which the constituents are not uniformly mixed. They are easily separable. So example, you are adding the pearls and pebbles. When you mix them, you can easily separate them. The second type is the homogeneous mixtures or solutions, in which the constituents are uniformly mixed, such as if you're adding salt and sugar, then it is very hard to separate the salt and sugar because they look same, their size is same, and so on and so forth. So that is called the homogeneous mixture. In other words, there is another example. So you can say salt water solution. So once you mix the salt and water, so they become like one. But if you want to separate them, it is not possible. So because they are uniformly mixed into the water. So that kind of mixture is called homogeneous mixture. But we are now calling it as a chemical compound because the salt water will have the water look of it and the taste as salt. So we know that a compound should not have any kind of a similarity between it from its constituents such as salt or water. But the salt water has these two combinations, these two properties, same as the constituents. That's why we are not calling it as a compound, but we are calling it as a mixture. So classification of matter. Matter is defined as the thing which has mass and which occupies some space. This matter could be two different ways. This could be fall under two again. So it could be a mixture or a pure substance. If it's a pure substance, the uniform material of definite composition with characteristic properties. If it's a mixture, then it has a variable composition whose parts can be separated by physical means. This pure substance, if you further break it down, that could be an element or a compound. Element is something which cannot be broken down into simpler substances such as hydrogen, oxygen, zinc, sulfur. And a compound that can be broken down into two or more elements such as water, zinc sulfide. Water can be broken down into hydrogen and oxygen, and zinc sulfide can be broken down into zinc and sulfur. As similarly, mixtures are two different types, homogeneous and heterogeneous. Homogeneous is a uniform mixing of different substances such as seawater, air, so on and so forth, because seawater has lots of chemicals in it along with the salt, and air has carbon dioxide, oxygen, and many other gases. So this is a homogeneous mixture where you cannot really separate them, by regular means, by look of it, or by physical means. Heterogeneous mixture, which is a non-uniform mixture of different substances which remain distinct. Example is wood, concrete, and so on and so forth. So which you could definitely separate them by physical means. Boiling and freezing point temperatures. You can see that if it's a liquid air, then you can see that its boiling point temperature is negative 196 degrees Celsius. And when you heat it up, then you can see that nitrogen has boiled away and the oxygen remains in it. And you can see that if it's liquid nitric oxide, which is 152 degrees Celsius, then you can, when you burn it, then all the nitric oxide will be boiled away. And then you can see that because the air has different type of gases in it, so you can see that the nitrogen, which has the low uh, melting point, it already melted away. I mean, sorry, yeah, boiling point, it boiled away, and the oxygen, which has the high um, boiling point, it remained in the water. But if you see this one right here, it's all liquid nitric oxide, so which has the same freezing point, I mean the freezing or the boiling point. So if you heat it up till that degree Celsius, then it went all the way up to, all it's completely boiled away. And I'm sorry, I think I said it's negative 196. It's 196 degrees Celsius. Loss of definite proportions. So if you're adding 100 grams of oxygen with the 88 grams of nitrogen, then you would get 188 grams of nitric oxide. So it means for every 100 grams of oxygen, you need 88 grams of nitrogen, and that would give rise to how much ever you add, that much exactly you would get the nitric oxide. So we need, for every 100, you need only 88 grams of nitrogen to make the nitric oxide product. Let's say that if you are adding more nitrogen, instead of 88 grams, if you are adding 12 grams of nitrogen extra, so this 100 grams of oxygen will take only 88 grams of nitrogen from here and form the nitric oxide of 188 grams, and the rest of the 12 grams of nitrogen will be unused. So you have to add just the same proportions of the material to react. If you add any excess, that will be remained unused. The atom. John Dalton proposed the atomic theory, which provided the basis for our modern understanding of the matter. According to this theory, all matter was composed of basic particles called atoms. Atoms are the ultimate particles of any element. Molecules that are ultimate particles of a gaseous compound. The ultimate particles of the liquid and solid compounds may be atoms or molecules or ions. Because it's a solid, the atoms could be, treated as the smallest particle. But if it's a liquid and gas compounds, then you could usually be thicker compounds. We call it as a combination of two or more atoms as the molecule. So those could be the constants of that particular material. So for example, several common molecules, when you hear this oxygen, whenever you see this oxygen, you will not see it just as it is O, but you will see two oxygen atoms stuck together. Water, H2O, you see that two hydrogen atoms stuck with the oxygen, not hydrogen. Some other examples are given here, ammonia, NH3, and so on and so forth. Another example is sodium chloride crystals, which is a combination of the sodium and chlorine ions.